Hi everyone, this is Kiko. Today I'm going to show you how to use a CASIO calculator to handle a binomial distribution. This topic was suggested by the student Paul Jimenez. So, assume there's 30 people in your class and all of you get the same disease. There's a drug available which has a success rate of 75%, meaning that 3 out of 4 people who take this drug get cured. So, some natural questions which may arise may be, what is the probability that exactly 5 of you get cured? What is the probability that between 5 and 15 of you get cured? These are the kind of questions we can answer using the calculator on a binomial distribution mode. Here we can see clearly a situation modeled by a binomial distribution, as in if x denotes the discrete random variable that counts the number of students in this class that get cured, then we have a binomial distribution with 30 trials and the probability of success in one trial is 0.75. Let's go to the calculator to put all this in. So in the main menu, I'm gonna go to statistics, and then this table may remain empty, may remain full of your things. It doesn't matter, we're not gonna use this. So we go to the tab called distributions. We see it's very intuitive. We find clearly the binomial distribution, and there's 3 tabs here. They correspond to 3 levels of difficulty that we may find in some questions. So the first level of difficulty may be, what is the probability that exactly 25 students in this class get cured? Then we would go to the first tab. If this is the first time you enter in this mode, you will probably have this in list mode, as in the data will be assumed to be taken from the tables that in my case are empty. When we want to use a theoretical distribution, we don't want anything on the list. We want to use this as a random variable. So we're gonna select variable here. Once you do this once, it will stay like that until you change it, if you ever do it. If you're an IB student, an International Baccalaureate Diploma program student, you will never need the list thing, really. What I put here is precisely the data from this question. The number of trials of this binomial distribution is 30. The probability of one success in one trial is 0.75. And we want to ask about the probability of x being 25. If we fill in all of this and we click on execute, then we get this probability, as in approximately 10.47% is the probability that exactly 25 students in this cohort get cured. Moving on to the second level of difficulty in these kind of questions. They may be asking, what is the probability that exactly between 5 and 20 students of this class get cured, both including 5 and 20. Then, since this is not what happens at one particular point as before, as in x equals 25 at one point, 25, but we're computing some cumulative probability with between one number and another number, all this range, then we're gonna go to the second tab where this C that stands for cumulative. Now, we want to put these lower and upper bounds corresponding to those numbers that we said, as in probability of between 5 and 20 students being cured. If you notice, the number of trials and the probability P will stay the same. So once you introduce the data of one binomial distribution, regardless of the tab that you choose out of the 3 that we're considering now, that data will stay there. Again, you go down to execute, calculate, and here you go, approximately 19.66% is the probability that between 5 and 20 students in this class get cured. Now, The third, more complex way in which questions may be asked is in a somehow inverse manner. That's why we're gonna need the inverse button. In this case, the question is, so if I know that the probability that at most X students get cured is 0.19659336, this number I've copied here, then what is this value of X? What is this at most X students get cured? Why is this called area, really? If you've used normal distribution or any continuous random variable, it will make sense to you, because in that context, probabilities are just the area under a curve. In a discrete setting such as a binomial distribution, it doesn't make that much sense, but I guess they just use the same title. So here's where you put that probability that you know. So if you go to execute, you'll get this answer 20. So what is the meaning of this 20? Well, this just means that the probability that at most 20 students in this class get cured is this approximately 19.66% that we input. And that's it. Those are the three buttons that appear under the binomial distribution section in this CASIO calculator. If you have suggestions on more videos you would like to see on this topic or maths in general, then use the comment section below. Thank you. Bye.